Hey, yes, I'm Kevin Sikowski from the University of Toledo, and we'll look at paving materials and how that impacts urban heat island. And I had given him some, general ideas. We talked about the different topics he could do, and he chose urban heat island. But he came up with this project pretty much on his own, and I was so proud of him for the effort he put in, and then the creativity in coming up with the project and following through on it. Like Ariana said, he's in class right now. He's a freshman at the University of Illinois, I believe. Now I'm in my car because I'm just coming from a City of Toledo meeting in which I presented some of Will's work to the Urban Tree Group and how those paving materials also affect urban heat because we're looking at trees and how that affects urban heat. Anyway, very, very happy with Will's work.
Awesome. That's really great that you were able to present his work in a real scenario. All right. So here is Will's presentation.
Hi, I'm Will Guth, and first off, I'd like to thank Professor C of the University of Toledo and the NASA N3 team for this amazing experience. It's been a true honor to learn under the guidance of Professor C. Okay, let me share my screen. My presentation is entitled The Impact of Pavement Materials on the Urban Heat Island Effect in Urbana, Illinois. I'll start off by breaking down what an urban heat island actually is. An urban heat island is essentially, an urban heat island occurs when a city replaces natural land cover with pavement, buildings, and other materials that absorb heat better than the natural land cover that pre-existed before them. And my project measured the temperatures of 5 different pavement materials over the period of 30 days in Urbana, Illinois, and aggregated them into a single image. The effect is significant because it increases it's significant to several disciplines, including atmospheric sciences, material science, civil engineering, public health. Further research is necessary to address the increase of ozone-based pollution, the impact of global warming on city-dwelling populations, rising energy and transportation costs, damaged infrastructure due to roads buckling due to very high heat, and growing health risks to vulnerable populations such as the elderly and physically disabled. My research method was designed to test the extent to which 5 different pavement materials affect the temperatures of their immediate surrounding environments, especially on the scale of entire cities. Previous research had investigated the properties of cities that make them uniquely better at trapping heat. This research provided a lot of evidence that the heat trapping behavior of cities is majorly due to the thermal mass and low albedo of common pavement materials such as asphalt or concrete. And supporting research has also focused on mitigation methods applicable to the UHI effect. A number of these studies put emphasis specifically on the materials that compose these cities. For example, Akbaria et al. Detailed a bunch of developments in the fields of high albedo materials and urban green space as strategies to keep cities cooler. And here is a graph on the amount of heat stress on a person in rough in rough i- in rough like zones of relative comfort for a human and potential danger to a human. Um, all of my field readings of my ground temperatures were collected with an Atexity laser grip 800 infrared thermometer at a distance of 16 inches from the surface of collection. The thermometer has a tolerance of plus or minus 1 degree Celsius. These measurements were all taken at 5 sites composed of different pavement materials: asphalt, brick, concrete, oil and chip, and permeable pavers within the city boundaries of Urbana, Illinois. For data analytics, my project used a portion of the scripts developed in a study by Coimbra et al. With several bits of customization and modification to work with primarily Whittaker Henderson smoothing, which I'll talk about later, as well as composite imaging from multiple satellites. And then the data was superimposed over a map of the different pavement materials used in the city of Urbana, which I got from the city engineer. The satellite imagery that was produced from the data visualization after calibration reveals that a lot of these there is a visual correlation between these areas that create sort of these bubbles of high heat. And there in areas with lower normalized differential vegetation indexes also tended to be hotter in general, as I'd expected. There's a strong correlation between paved areas and high land surface temperature. In particular, asphalt, oil, and chip and concrete are kind of the worst offenders. Low albedo is likely a strong contributing factor to this, as well as low exposed surface area. And the reason why I think low exposed surface area is a significant factor is because of the way that the standard deviation is correlated to the temperature for that day. It rises significantly, which is a behavior that would be expected if you were measuring the difference between a monolithic sort of material and like a heat sink material that is designed, and a heat sink type material that is designed to use the temperature gradient between it and its surroundings to force heat out of it by maximizing its surface area, because a heat sink or a similar device becomes much more efficient as temperature rises. So at low temperatures, the temperatures are of the materials are relatively close, but at high temperatures, the permeable paver and terracotta brick do not actually rise as much with the other materials on here, which can't really be explained that well with albedo alone. There's not really that much difference between concrete and between concrete and the permeable paver and terracotta brick in terms of their albedos. Even though permeable paver and terracotta brick are remain at much lower temperatures. So it although asphalt and oil and chip having very low albedos definitely absorb a strong contributing factor to why they're so hot. It is definitely the fact that they have such low albedos. However, I don't think that is the sole explanation. My temperature map is a composite of data taken from Landsat 8, Landsat 7, and MODIS satellites, with the addition of Whittaker-Henderson smoothing, which was inspired by a novel approach I read in a study by Kong et al. To image processing. Pixels were calibrated to known ground measurements and then processed through Whittaker-Henderson smoothing, which is an algorithm which is most typically used to reduce noise in 2D in a two-axis graph, but it can also be applied to images. And the way that it works is it essentially makes pixel, like any noisy data points, fit better into a curve. And the image was then superimposed over the pavement map, which is color-coded by material. This does still show that there is a strong correlation between albedo and heat trapping properties of a material. However, further research is still needed to classify all of the specific qualities of paving materials that contribute to their heat trapping properties. There are likely other properties that make a material more favorable at mitigating high temperature. For example, as I mentioned earlier, a material not being one solid uninterrupted thermal mass seems to make a major difference, and having a high surface area seems to make a major difference in terms of temperature. For example, how can we make practically, how can we make high albedo paving materials also have a high surface area so that they can diffuse heat quick, so that they can both absorb as little heat as possible and diffuse heat as fast as possible. The further study is still needed on the actual impacts of the urban heat island effect to decrease energy costs, air pollution, and heat-related illnesses. And here are all of my sources and my code. And I'd like to give a big thank you to everyone on this slide, and another big thank you to Dr. C and the NASA Neurodiversity Network, NASA itself, the Education Development Center, Sonoma State University, NYSCI, the University of Toledo, WestEd, and the City of Urbana.